right, I'm going to be working some problems from our objective number 2 on colligative properties. It is concentration expressions, objective number 2. The first topic, it says, is the topic of molarity. And molarity, we know, is moles of solute per liter of solution, moles per liter. Let me read for us letter A. What is the molarity of a solution made by dissolving 10 grams of ammonium sulfate into 500 milliliters of water? 10 grams of ammonium sulfate. So we'll put that into a formula, NH4 taken twice, SO4. And we're going to place that salt into 500 mils of water. And we're trying to solve for big M, the molarity of our solution. First, we'll need to do a conversion of our grams of solute into moles of solute and then put that over our 500 mils, but into a liter unit. So we have a little molar mass addition here. 10 grams of NH4 taken twice, SO4, times 1 mole set over the formula weight of NH4 taken twice, SO4, and I'll hit that on our calculator. 14 times 2 on the nitrogens, a total of 8 from the hydrogens, 32 coming from the sulfur, and 64 from the oxygen, gives us a molar mass value of 132 grams. 10 divided by that molar mass, and I have 0.07, I'll round 0.076 moles of our solute. Now that I have the number of moles, we can solve for big M, molarity unit, by taking that value, 0.076 moles, setting that over 0.5 liters of water. And our value for big M, the molarity of our solution, comes out to be 0.1515 repeating, so I'll carry 2 decimals, 0.15 molar units of ammonium, NH4 taken twice, sulfate, SO4. Let's read for the letter B under that category of molarity. What is the molarity of a solution made by diluting 250 milliliters of a 3.5 molar to a 750 ml total volume? There was a key word here. It was dilution. When I think of a dilution, it's a known concentration, just adding water to it. So we're using our formula M1V1 equal M2V2. Key word when we read that problem, the word dilution. Set of first variables gave us 250 mLs at a concentration of 3.5 molar. What would the new concentration be when we dilute it to a new volume of 750 mLs? Notice that the volume units are the same on both sides, so I'll go ahead and hit 250 times 3.5 divided by 750, and I come up with 1.17 molar. 1.16 repeating, so 1.17 molar solution. In our next category here, for our second problem, we have a title called molality. And this is a new unit for us. Molality is moles of solute per kilogram of just the solvent. So a little bit different than the big M molarity. This is little m molality. And let's go ahead and read for the letter A. It asks, what is the molality of a solution formed by dissolving 50 grams of calcium fluoride in 750 grams of water? Whoops, that says 750 grams of water. We have a little mole map work to do, so pretty straightforward here. 50 grams of our solute, CaF2. Using a molar mass to convert, I'll need to add that for us. We have calcium contributing 40, plus 19 times 2 from the fluorine, about 78 as its molar mass. 50 divided by 78, and I have 0.64 as our number of moles. .64 moles, and then I can just do this quickly over on this side. Molality will be 0.64 moles divided by 0.75 kilograms of our solvent, water, moles per kilogram, divided by 0.75. And how about 0.85? Check me on your calculator. 0.85 molal units of calcium fluoride. Let's read for the letter B. What is the molality of a solution formed by dissolving 50 grams of carbon tetrachloride in 100 mils of benzene? Density of the resulting solution can be found as 0.847. This looks a little more involved. I'm trying to get my microphone set. Sorry for the delay. So here I go. We have 50 grams of carbon tetrachloride, CCl4. We're going to place that into 100 mils of benzene, and benzene is C6H6. Not necessary to know that formula, but that is the molecular formula for that organic molecule benzene. Alrighty, so at this point, we got a little mole map work to do. We have 50 grams of CCl4. We have to convert that into a mole. We need moles of solute, so I'll need to add a carbon tetrachloride molar mass, 12 plus 35.5 times 4, and I get a total mass of 154. So 50 divided by 154 converts it into a mole, 0.3246. How about we'll round a little bit to find 0.325, we'll say. Now here's the other trick. We have 100 milliliters of our benzene solution, C6H6 benzene, but we need it to be in kilogram, and that's where the density unit will come out. Here I can see that there's 0.847 grams for every 1 milliliter. So that again is given to us in terms of the density of our solution. Notice how the milliliter unit cancels and we've converted to gram. So 100 times 0.847 is 84.7, just moving that decimal around, which is 0.0847 kilograms. So solving now for molality of our solution, 0.325 moles of solute per kilogram of solvent, 0.325 divided by 0.0847, and I get 3.84 molal units. There's an integrative exercise. Let's take a peek there at the integrative exercise. I'll read it for us. Ascorbic acid, vitamin C, is a water-soluble vitamin. A solution that contains 100 grams of ascorbic acid, C6H8O6 is vitamin C called ascorbic acid, is dissolved in 500 grams of water, and the density of this resulting solution is 1.22 grams per mil. And that temperature provided is 55 degrees. We need to calculate the molarity and the molality. Well, for either one of those, we're going to need to turn our moles, our grams of solute into moles of solute. So that'd be a good first step for both parts. 100 grams of C6H8O6 converted to a mole will need its molar mass. Let me add that with you. 12 times 6 from the carbon, plus 8 on the hydrogen, plus 16 times 6 on the oxygen. I found 176 grams. And if I convert 100 divided by 176, we get the number of moles, 0.568. And now that shows me moles of solute, which we need for both molarity and molality. The first of our problems here is big M, molarity units. Big M is moles of solute per liter of solution. Well, we just determined 0.568 moles of solute, but we have grams of water. Now, remember this down here, this is of the entire solution, isn't it? The solution contains two parts. It contains the solute and the solvent. So when I'm converting my grams of solute plus grams of water, we got to work this out to find total volume. Remember that density, this density is of the solution, not just of the water, not just of the solute, but when they're mixed together. So let's do some work here. We've got to figure out the volume, but we have two masses. 100 grams of my solute and 500 grams of my solvent give me a total mass of 600 grams of the entire solution. The mass of the solute plus the mass of the solvent will give me the mass of the entire solution. 600 grams of our solution, and now we want to convert into a milliliter. So here comes the density conversion. We know that 1 mil contains 1.22 grams. Notice why I put that 1.22 on the bottom. I need the gram unit to cancel and convert out to the volume. 600 divided by the density of 1.22 is showing me a volume of 491.8 milliliters. I added the two components to get the mass of the solution and used the density to convert my gram unit to a volume unit by dividing. Now I have the number I need over here to find molarity. 0.4918 liters of solution. Moles per liter, moles of solute per liter of the whole solution, and let's solve. 0.568 divided by 0.4918 gives us 1.15 molar units. Big M for molarity. Now what if we had to ask, is letter I asks us for baby M, molality. Molality, of course, is moles of solute per just kilogram of solvent. And we have the numbers we need, pretty straightforward calculation at this point. 0.568 moles of our solute per kilogram of just the solvent. And notice that was provided up here. 500 grams is 0.5 kilograms of just the water. 0.568 divided by 0.5 is 1.136. I'll carry it so you can match your calculator, and that's a baby M for molality. Here is molarity, and here is molality. Pause here and just digest the second objective, making sure that you understand the difference between molarity units and molality units, and you'll be ready to start Objective 3, colligative properties.